Quadratic Equations, the Quadratic Formula. In this module, we've been focusing our attention on solving quadratic equations. That is, equations that can be written in the form ax squared plus bx plus c equals 0. Or more simply put, equations where the highest degree is 2. Now, in the previous topic, we learned the technique of completing the square. With completing the square, we can solve all quadratic equations. Unfortunately, sometimes completing the square gets a bit messy, especially when fractions are involved. So in this topic, we're going to learn about yet another method for solving all quadratic equations. It's actually a formula that will allow us to skip over any messiness in completing the square and land directly on the solution set of our quadratic equation. Our quadratic formula is as follows. The solutions to the equation ax squared plus bx plus c equals 0, with a not equal to 0, are given by x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Note, you want to commit the quadratic formula to memory. In other words, you want to memorize the quadratic formula. It comes up again and again and again, and it's worth your time to store it in long-term memory. So, where does this quadratic formula come from? It comes from completing the square on a general quadratic equation, ax squared plus bx plus c equals 0. That is, solving this quadratic equation by using the method of completing the square. Now that derivation is actually valuable. It's interesting and useful to see where algebraic formulas come from. I'm going to go through it step by step right here, right now. If you're interested, follow along. If not, skip this derivation and go on to the examples. But again, I think this is worth your time to actually look and see how a formula is generated using algebra. So, let's take our general quadratic equation, ax squared plus bx plus c equals 0, and let's solve for x by completing the square. Recall that our first step is to put our x terms alone on the left side, which means for this example that we'll need to subtract c from both sides of our equation. Doing so, it will give us ax squared plus bx equals negative c. Now the next thing we want to do is make sure we have a lead coefficient of 1. Notice we have an a. So we need to get rid of that a, and to do that we need to divide each term in our equation by a. That gives us x squared plus b over a times x equals negative c over a. Now we're ready to make a perfect square trinomial on the left, so we want to add a blank to the left side and the right side. And to find out what goes in the blank, remember, we want to take half of our middle coefficient. Our middle coefficient is b over a, and so we want to take half of that. And what does that give us? b times 1 is b, and a times 2 is simply 2a. This is our magical number. What do we do with that magical number? Well, we square it. So we have b over 2a squared, which simply gives us b squared over, and if we square the bottom, that gives us 4a squared. Following along? That's what goes in both of the blanks. b squared over 4a squared. b squared over 4a squared. Now, to continue completing the square, we want to rewrite this perfect square trinomial as a binomial square. And how do we do that? Well, we take our magical number, in this case b over 2a, and we put it inside our parentheses. So we have x plus b over 2a quantity squared, which is equivalent, if you multiply it out, to this perfect square trinomial. Now on the right side, we want to simplify by combining these like fractions. Well, on this side, they're actually not like, but we're going to get them to be like fractions first. So we have negative c over a plus, and then we have b squared over 4a squared. Now we need to get like denominators. Our common denominator is going to be 4a squared. That means my first term needs to get multiplied by both a 4 and an a. 4 times a will give me 4a squared. And if we do it to the bottom, we have to multiply likewise to the top. So that tells me I have negative 4ac all over 4a squared plus b squared all over 4a squared. And putting these together, because they're now like fractions, we have negative 4ac plus b squared over 4a squared, which I'm going to write with my b squared term first. That means that this right side simplifies as b squared minus 4ac all over 4a squared. Are you with me? How do we finish? We use the square root property. We have a quantity squared equals a number. To finish, we take the square root of both sides, so that tells us that x plus b over 2a equals plus or minus the square root of this whole side, which is b squared minus 4ac all over 4a squared. What do we do now? We isolate x. That means we subtract the b over 2a from both sides. Doing so, when we subtract, it brings it over to the right as negative b over 2a plus or minus, and I'm going to simplify as I go here. This is the square root of b squared minus 4ac all over, and the square root of the bottom, well, the square root of 4a squared is simply 2a, because the square root of 4 is 2, and the square root of a squared is a. We have like denominators, and we can put these terms together, and that leaves us with the fact that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And hopefully you recognize this as the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's simply taking a general quadratic equation and completing the square on it. So what that gives us is a formula that allows us to solve any quadratic equation. Now that's powerful.